Now we're going to define our main interface for videos repository. This is the property that everyone can use to observe videos from the repository. We'll start by declaring a property videos with a type of live data of list of videos. We don't need to make a method for this, since live data will be smart and only run the query when an activity or fragment is listening. Note that we want to provide video entities, not network video or database video, because those are implementation details of the repository. Since the repository is supposed to hide those details, it wouldn't be a good API to expose them here. Callers will use domain objects. They don't care if the data came from the network or the database or somewhere else. We'll want to run our database query, getVideos, which will give us a live data, though our database returns a database video instead of a video. To map from database video to video, we'll use transformations.map. Transformations.map lets us convert from one live data to another. We can use the helper as domain model that we defined earlier to convert from a database video to a video. Just like the database query, the transformation will only happen when an activity or fragment is listening, so we can declare this as a property safely. For our app, we're going to use a very simple refresh strategy. The caller of the repository is responsible for specifying when to refresh the data. In real apps, your refresh strategy may be simple like this, where we just reload everything on request. Or it can be very complex, and it can automatically refresh the data, keeping an eye on minimizing bandwidth or caching the data that the user is most likely to use next. And with that, we've finished our repository. Repositories can sound complicated, with words like separations of concerns and dependency injection. But this is all there is to a basic repository in practice. It's just a regular Kotlin class with methods that we define. Dependency injection can be done as simply as a constructor parameter, and we implement an offline caching strategy with 2 functions and 9 lines of code.